everyone. Welcome to DA 104, the Road to Intelligent Transportation. My name is Chris, and along with my peers down here, Zeph and Andrew, we're going to be talking to you today about how Google and the Colorado Department of Transportation, CDOT, are leveraging Google Cloud Platform to bring intelligence, efficiency, and interoperability to CDOT's transportation network. A quick show of hands. Who commuted into San Francisco this morning? All right, half or so. Who enjoyed it? And if this was a interactive session, I'd ask you in the back, did you go by bus or by shuttle so you could actually have some relaxing time? And I would expect most of us didn't. So while we're not solving that problem today, that is one of the goals that we have in this partnership, is to try to alleviate traffic congestion to help all of us improve our commutes. Before we dive in, a quick reminder, if we can accept questions through the Dory app, which you can link to from the next application, and enter your questions. And at the end, we will have time for both live Q&A from the mics as well as answering questions from the Dory. So let's dive in. So safety has always been a #1 goal for departments of transportation. While fatality rates have decreased over the years, in recent years, we've seen an uptick in the number of fatalities. So what's causing this change? Well, the number of vehicles on the road are increasing faster than the number of people. From 2016 to 2017, we saw an increase of 1.6% in the number of registered vehicles compared to a 0.8% increase in the overall population. This is leading to more congested and dangerous roadways. And DOT budgets aren't increasing. If anything, they're shrinking while construction costs are rising. To answer this transportation problem, we shouldn't continue to do the exact same thing we've always done, which is building more roads. While that's definitely needed, it's something we'll definitely do. There's not enough space to continue to do that, and also it's extremely costly, and it takes years to see an impact to congestion for new construction. One way we could improve upon and optimize traffic management is by viewing the roadway as a highway for information versus a highway that carries vehicles. DOTs have spent decades deploying traffic management solutions that produce massive volumes of data. Side-fire radars, toll meters, weather stations, traffic cameras. Harnessing this data from the roadway will help us optimize traffic both now and into the future. The good news is that the data we need does exist. The not so great news is that it generally resides in very different places and is generally disconnected, leaving us with a fragmented view at best of what's happening on the roadways. And there's many different transportation data sources that exist, but again, they live in different places. Critical data that we could take advantage of now, such as enriched, GIS data, Amber Alerts, traffic cameras, are all over the place. And even key data sources like Waze and Google Maps. Without a clear understanding of what's happening on the roadways, our communities pay for mobility, and sometimes with their lives. But what if we could bring all of this data together and even let data be the driver for traffic management? We could enhance situational awareness, leveraging current and historical data, both situational data, weather data, traffic data, to respond to traffic incidents in near real time, the moment they happen. We could coordinate response across courtesy patrols, towing, maintenance, law enforcement, emergency response, to respond to an incident based on where it is from community feedback. We could assess roadway needs using data points like traffic volume and frequency, weather events, community feedback, to understand where we need to do repairs in a predictive way on the roads. And with all this data brought together, in a view that you know best, an interface such as Google Maps, you can harness the data to answer some key questions. Things like, how has traffic changed over time? What alternate routes can be utilized? When is congestion expected to peak? And where are the most trafficked roadways? We can visualize this data with Google Data Studio or partner solutions from Looker and Tableau. You can overlay your insights on a real-time view using Google Maps. Once the data is centrally organized and available for both historic and real-time analysis, we can make data-driven decisions, helping to make roads and drivers safer. So why did CDOT choose Google Cloud to build its data analytics system? Google supports data at petabyte scale, securely, with our best-in-class data analytics and machine learning capabilities to inform real-time decisions and to operate roadways. For almost 2 decades, Google has been advancing the state-of-the-art for data analytics, starting with our initial research paper on the Google file system in 2002, going to our MapReduce research in 2004, and our NoSQL database big table research in 2005. We've been advancing the state-of-the-art and creating a revolution that the open source community has taken, and around that have built what many would say is the best-in-class data analytics system in Hadoop and in Apache HBase. But Google didn't just stop doing our research and engineering in these areas. We've continued to advance the technology year on year to help power all of our services that we bring to you. For example, Colossus, which is our next generation file system, or Dremel, which is our scalable SQL engine, to Flume and Millwheel, which are our next generation data processing pipelines, and to today, where we're using TensorFlow for scalable machine learning. And while we're using these for our own services, we've also made them available to you, to CDOT, in Google Cloud Platform. So you can take advantage of these same services that have been proven inside Google for years to now power your products and your applications and your services that you're bringing to your customers. And like I said, this infrastructure powers Google's 8 billion plus user services: Google Search, Chrome, Google Maps, YouTube, Gmail, Google Drive. But let's pause for a minute. Let's actually think about what these systems are at their core. And are they actually what they appear to be on their face? Is Gmail just a system for sending and receiving email? Is YouTube just a video content delivery system? Or is Android just a mobile operating system? What I'd argue is that these are actually massive, globally scaled analytical engines that leverage machine learning to bring personalized results to our users when and where they need them. Google Cloud delivers data analysis through industry-leading analytics and ML when and where you need them, with security and privacy in the forefront of our design. We have 4 key design principles for our data analytics stack, and these are top of mind for our customers. First, our serverless data analytics infrastructure, our leadership in that space. We are designing a data analytics stack, or we have designed a data analytics stack for the public cloud paradigm. We're not lifting and shifting traditional on-premise architectures into the cloud. This enables our customers, all of you, CDOT, to instead of focusing on traditional infrastructure like they normally would do, to focus on analytics, which is really what we want, is to focus on the analysis of the data that we're collecting. We're building and offering a comprehensive set of core data analytics workloads, from data warehousing to streaming data analytics to business intelligence to AI and ML. Unlike vendors with one-off solutions, this allows, our approach to this is a much more holistic view of a data analytics platform. We also let our customers operationalize machine learning end-to-end. ML training and prediction is just one piece of the puzzle. But offering up a seamless ability to collect, store, transform, process, and prepare data for ML gives us an end-to-end solution. We're deliberate in making our ML stack simpler for organizations to adopt so they can derive information from their ML initiatives faster. And to finish off, we know this. Google has proven the usefulness of this infrastructure through the services that we offer. We're at the forefront of data analytics and ML innovation for the past 2 decades, and the solutions and frameworks are available to our customers today who are now adopting this and running their mission-critical data analytics apps on top of Google Cloud. But it's not just the cloud technology that Google offers that's important here. It's also our history and innovation in the transportation space. Organizations need reliable, real-time data within user-friendly views to empower employees to respond to customers' demands and needs. Google Maps offers visualization, navigation, and analytics to help leading enterprises chart new territory and to build transformative new opportunities. Nobody understands cities and what happens within them than the people who live there. Waze offers up a data exchange partnership where we provide publicly available incident and slowdown data to our government partners. Governments can then take that data to both help them respond to accidents more effectively and also analyze congestion to find where they could make improvements. Driving today is not as safe or as easy as we would like, and Waymo, their mission is to make it safe and easy for people and things to move around the world. They're building a completely self-driving technology that will improve mobility by giving people the freedom to get around and help save thousands of lives that are today being lost to accidents. So let's get into DAISY and what it is. So first, the acronym, Data Analytics Intelligence System. There's a flurry of activity at CDOT, which is intended to improve the acquisition, processing, management, curation, and quality of the data sets CDOT has. Tackling those fundamental problems will allow CDOT to enhance the utilization of data, create applications, and solve use cases that are becoming critical in the rapidly transforming transportation space. Wes Maurer, who unfortunately couldn't be here, the head of policy and innovation at CDOT, along with the mobility operations team, is leading the charge for adopting cloud computing and real-time data processing, with the goal of enabling data analytics and modeling capabilities across CDOT. The DAISY platform has the potential to solve many use cases, delivering better decision support, and moving us closer to data-driven decision making. There are many transportation use cases that CDOT focuses on, and this is just a quick sample. For example, transportation planning, winter operations, or situational awareness. These use cases are supported by a myriad of disconnected systems, such as SAP, which has all budgeting and financial information, Salesforce, which holds construction and project details, to roadway sensors for real-time mobile operations. DAISY is the data services and systems layer which aligns the use cases and the requirements with transformed, enriched, and coalesced data from source systems, and empowering end users to achieve CDOT's key performance measures. DAISY will also be the hub for enabling new applications across the DOT by delivering historical and real-time data and also leveraging AI and ML for predictive analytics. So with all this in mind, Google capabilities with data ingestion, exploration, and data science, preparation of processing and ML training, tuning, and predictions, this architecture enables DAISY to become a serverless analytics engine for a complete end-to-end lifecycle, delivering on CDOT's mission to bring intelligence and insights to the transportation space, to their transportation network. So now I'd like to introduce Zeph, who's going to come in and do a deeper dive into building DAISY with data.
Thanks, Chris. My name is Zeph Delgadillo. I'm a technical lead on the DAISY project working with Google Cloud and CloudReach. So when we kicked off this project several months ago, the first thing we had to do was assess all the different data sets that were available at CDOT across their entire kind of technology ecosystem. First thing we really discovered is that there's kind of two major categories of data for a DOT or for transportation. That's around either geospatial data or streaming video data. And Andrew's going to talk a lot about the video streaming data in a second, but I'm going to go into some of the geospatial data and some of the kind of capabilities we're unlocking by using that data. Geospatial data is really just any type of data that has a geographic component to it. So a set of coordinates associated with that data. So we then broke that data down into a few different kind of major data domains that are critical to a DOT operation. And that's really around speed, weather, and incidents. So speed, how fast are vehicles traveling relative to speed limit and kind of moving averages, and then vehicle volume on the highway system. Right now that's primarily detected using some side-fire radars that are fairly old. Some of that data that often comes out of it is or buggy or inadequate. Weather data. Weather data right now for CDOT is collected using these road weather information system devices that also live alongside the roadway. So this becomes kind of an IoT play as we start getting into this. The third data domain is around incident data. So basically any kind of traffic incident that gets logged by the DOT operators into their kind of traffic management system. So those are what we're calling sort of the legacy data sets. One of the things we wanted to do was enrich that with some new data so that we can get kind of additional value out of data sets that are available publicly or through different organizations. So for speed data, we brought in data from Waze. Waze is crowdsourced data that we can track when jams are starting to build up on the highway systems. And that gives us a better picture of the roadway health according to speed. So right now, CDOT's detecting speed using an algorithm that really only takes into account the data coming from side-fire radars. So by bringing in Waze data, we can get kind of additional value out of that. Weather data. This is a really cool data set produced by the National Center for Atmospheric Research called Pike Alert. Pike Alert has these vehicles kind of traveling up and down major trucking routes in Colorado, particularly I-70, and it detects road conditions. So if there's an icy road or there's snow on the road, you'll get back data around snow depth or whether that road needs to be treated. Incidents. So Waze is another great data set for incidents. Crowdsourced accidents that people are putting in can be now added in addition to the DOT events that are getting logged. So we wanted to make this data a little bit more accessible to DOT users. Chris mentioned that this data existed in a lot of silos all over the DOT. It was in Salesforce, SAP. We had to do this massive Oracle data warehouse migration. So we basically brought in terabytes of historical data into Google Cloud BigQuery. And we set up this sort of abstraction layer on top to make it a little bit more accessible to someone who has a lot of domain expertise in the transportation space, but doesn't want to be bogged down with trying to remember what table to join on to derive value out of those data sets. So we created simple kind of business-friendly entities at the top view layer in the form of views in BigQuery and created a data set called DAISY Mart. With that, we're using a business intelligence tool, Looker, that utilizes these same entities to kind of democratize this data a little bit more. So here's kind of a simplified view of our architecture. Really, it's all kind of centered around PubSub. PubSub enables us to basically use streaming data across all these different data sets. So even in cases where we're batching in data, so Waze, we might be reaching out every 5 minutes to get the latest Waze data, we could still translate it to PubSub and have a series of PubSub topics that are kind of like, you could think of them as like spigots you would attach a hose to pull in that data. So it enables any really application or user to pull in data from Waze or data from the IoT devices and build out their applications with it. We're pushing all that data into BigQuery and Bigtable. And on the right, you can kind of see like how we're looking at DAISY. It's sort of like a three-pronged platform. You have event-driven data in PubSub, like I mentioned before, near real-time data in Google Cloud Bigtable, and the analytics layer that uses BigQuery and Looker. Geospatial data. So I mentioned before that geospatial data is it's kind of special. It's kind of important to CDOT. And we wanted to use some kind of best-in-class tools to sort and analyze that data. So GeoMesa is our first one. GeoMesa is an open source tool for basically massive geospatial querying and ingestion. It stores in Google Cloud Bigtable, and it does all its processing in Apache Spark, so you can run it on a Dataproc cluster. It transforms indexes, and then it stores that geographic data for rapid access. So you can query basically on either time or some kind of geography. You could pick like a window of space on a map and then get all of the data available through there. GeoServer is the other tool we're using, and that's our mechanism to share that geospatial data. So it uses GeoMesa as its backend data store. We're running it on Google Kubernetes Engine, and it publishes data to really any kind of geographic data standard, including GeoJSON. GeoJSON has kind of emerged as a de facto standard for sharing geographic data over the web. So a couple use cases that, after a few months, really, we're able to unlock using the computational power of Google Cloud BigQuery. So CDOT has its concept of a road segment. The road segment is really just a stretch of road between 2 points going in a single direction. And that road segment has a set of geographic coordinates associated with it. So using Google Cloud BigQuery, we can basically attach these Waze accidents or incidents off to the road segments. So when you're querying, or someone who's a transportation planner is querying on the health of that road segment, not only do you get the events that the DOT logged, you also get the Waze accidents. So this is a really powerful new tool that we can unlock using the computational power of Google Cloud BigQuery that using their on-prem data warehouse just wouldn't have been possible. Enabling situational awareness and replay. So this concept of situational awareness is understanding what's going on in the DOT. So if you ever go to a DOT operations center, they've got all these maps and all these different camera views all over the place, and they're toggling between Waze and Google Maps, their own mapping systems, to kind of understand what's going on. So with the architecture that we built, we're enabling this mechanism to kind of build out some kind of situational awareness layer. And on top of that, we can now, using the platform, replay an existing event. So a few weeks ago, there was this big storm in Colorado. They called it a bomb cyclone. And we were able to capture that data using kind of our DAISY platform. And it gives us the opportunity to replay that event and watch how all these different layers kind of interplayed, so that a transportation planner can go back, review an event, and understand how they can better prepare for it in the future. Kepler.gl is an open source mapping tool produced by Uber, which I think is pretty cool that there's this sort of disruptive technology that we can now kind of reapply to the DOT, which has been around forever. So I'm using Kepler as just a mechanism to demo out this kind of GeoServer, GeoMesa data processing system that we've set up here. So this is kind of a cool video. It's we're basically replaying all of the Waze accidents that occurred during the bomb cyclone. You can see that they kind of just dipped to nothing here because so few people were on the roads. But this is sort of like, gives an interactive way of a user to kind of take a look at the roadway health and create sort of geospatial visualizations, which is a capability that would not have been possible in the previous ecosystem. Similar thing with speeds, so we can kind of detect highway speeds. It's going to go really red in a second. And the cool thing is that we're really animating kind of millions of entities right here that we're pulling in. From GeoServer, we're just getting that GeoJSON endpoint, pushing it into Kepler.gl, that Uber tool, and then we can immediately animate and then replay across a historical set. So this really is just a demonstration of the kind of future capabilities that we're trying to unlock. By building out this underlying platform and that infrastructure, we have a lot of really kind of powerful tools at our disposal. With that, I'm going to pass it off to Andrew. I'm going to be at the Google Public Sector booth, and I'm happy to go through kind of that demonstration of Kepler in a little more detail if you'd like to see it. Thanks. There you go.
Thanks, Zeph. Hi, everyone. My name is Andrew Schwartz, and I'm a product manager for Video AI here at Google Cloud. At Google Cloud AI, we have the mission to empower enterprises to transform their business with AI. For CDOT, video is a great example of this transformation. CDOT currently has hundreds of roadside cameras collecting valuable information every day. However, this information has not been fully utilized as it's been too difficult to reliably and scalably analyze these videos and collect the data from them. However, that is why CDOT decided to leverage the power of Google Cloud AI to help them bring intelligence to these legacy camera systems without the need for replacing them for higher resolution and higher processing power cameras. At Google Cloud AI, we offer two types of AI building blocks to help customers build or add human-like capabilities to their products. The first I'd like to talk about is the pre-trained APIs. The pre-trained APIs allow customers to leverage Google predefined data sets to meet common use cases and fully train models based on the latest breakthroughs in AI technology and research. The second is AutoML. Even for expert data scientists, it's quite difficult for them to train and program custom computer vision machine learning models, which is why we created AutoML. AutoML enables even non-programmers to leverage a simple user interface to create custom models. All they have to do is upload labeled data sets, and then with a simple click of a button, train a custom computer vision model fit to their specific domain or specific use case and deploy it to production. Today, building upon this, we're really excited to announce that we've added additional functionality to our video intelligence streaming, or video intelligence APIs in the form of streaming capabilities. Now enterprises have the flexibility to not only process large video archives that are stored in Google Cloud Storage, but also to analyze videos in real time and get actionable insights right on the spot. With live streaming support, we have initial support for live streaming protocols such as HLS, RTMP, and RTSP initially. So with the power of the pre-trained models and the streaming API, CDOT is able to bring intelligence to their existing camera feeds. For instance, CDOT leverages our pre-trained object tracking API to extract valuable information and detect different types of vehicles and track their movements throughout the day. This information helps them understand traffic patterns, as well as identify trends and make decisions off of it. Or they can leverage our label detection in AutoML to monitor road conditions, to identify whether it's snowing or whether there's snow on the road, which can further enrich weather data as part of DAISY. The streaming API allows customers to leverage or harness the power of cloud to do video processing at scale. But it gives them the flexibility to take the results and either process it further on Google Cloud or to view the results on-premise in their application. To help you get started and easily connect to the Google Cloud Streaming API, we provide AI Streamer, which is our ingestion library, and a set of sample code to easily process or chunk the videos and send it to the cloud for you. Here we provide a simple architecture or sample architecture for how you might connect and utilize the streaming API. AI Streamer takes in the video feeds and sends it to the cloud for analytics and storage. With this, you can then run the pre-trained video intelligence APIs to extract valuable information from your video feeds, and then pipe the results into Cloud PubSub, where that information can then be passed to your application in the cloud, such as it is for DAISY, or back to your application on site for a visualization. So what does this all mean? It means that when you can extract valuable video information, you can combine it with DAISY data, other DAISY data sources. You can solve real transportation problems. You can reduce costs. You can optimize roads. We can help you get home quicker from work. We can make the roads safer for you and have you spend more time doing what you love and less time spent on the road. Next, we'll kind of show a quick demo of one of our object tracking APIs running, or pre-trained models running on one of DAISY camera feeds. This is pre-recorded, but if you would like to see a live streaming demo, you can come by the public sector booth later today or later this week and see actually a live feed being ingested, as well as the bounding boxes overlaid for the different videos. So with this, you can track the movements of different vehicles crossing through an intersection and keep these data or store them as part of DAISY. Next, Chris will actually show you some information regarding this, around how much data is actually being extracted from these videos, even with a small number of cameras currently.
Thanks, Andrew. So to pivot on what Andrew talked about with the video the Video Intelligence Streaming API. A few weeks ago, we deployed video streaming infrastructure from CDOT's on-premise data center to Google Cloud, the DAISY platform. And we've been collecting data ever since on only 4 cameras. So I want to quickly just kind of give a view of how we're using this metadata, in addition to the bounding box, the video stream that you saw, how we're using this metadata to gain further insights that CDOT originally did not have. So CDOT has roughly 488 some odd cameras connected to their network, in addition to thousands of others that are connected over cellular. These cameras are all legacy devices. They're not intelligent. They're not giving data out. They're just live streaming so that an operator can view it. On the right-hand side, I have one of the cameras happens to be in south of Denver on I-25, and that's a still image of that camera. We've been extracting data around vehicle counts, both total by hour, by day, and averages by weekday. And you can see each of those heat maps accordingly. And now we can take these non-intelligent devices, extract data from them, and have insights into what is visible in that live stream. And this would correlate, if you look in the heat maps there, it correlates to increases in traffic volume throughout the day, aligning with what we would normally know as our commute times. So to give you an idea of the volume we're operating at here, so 4 cameras, they've been operating for 13 days. And over that time, we've ingested over 60 million data points for labels and over 21 million objects. Now, granted, not all of this data is necessarily useful for every use case, but just think you went from almost 0 data points besides what a human would see out of a camera to now ingesting all of this data into a scalable data warehouse in BigQuery. So now we can analyze it both real time as well as historical. So to give you a view of like where we're going, where we've been and where we're going, here's a tentative roadmap for what this partnership is going to go forward with. So starting in March, you see at the bottom, we did our executive review that closed out phase 1. For phase 1, we delivered a technical systems plan for the DAISY system. We built out core infrastructure for DAISY as well as multiple data integration pipelines. We also we're doing a full sync of all their historical data from their Oracle data warehouse, and we have a migration plan for that as well. We also delivered a technical system plan for a modernized Colorado traffic management system. Now going forward, we're looking to continue building out more of the core system, build out multiple data integration pipelines beyond what we have today. And if you remember the slide back, we had all those myriad disconnected systems. There's lots of those that we need to build pipelines and get into DAISY. So we'll continue to do that. We'll do a full migration of the Oracle data warehouse. We're building multiple real-time visualization interfaces, such as the example that Zeph showed with Kepler. We're also going to explore doing the development for a modernized Colorado traffic management system and modernizing and hosting their cotrip.org public-facing website in GCP, being powered by real-time modern APIs from DAISY. We're also going to explore building a data discovery platform and a real-time data hub that CDOT will use to both do data analytics broadly across the DOT as well as new application development. So in closing, CDOT and Google have partnered to build DAISY, which will aid CDOT in delivering on their key performance measures. For example, improved safety and mobility, increased social equity, highly responsive traffic operations, and collaborative data and information sharing and communications. So right before I end, I'll reiterate, if you want to see live demos of the technologies we've shown, go to the industry solutions area and the public sector booth specifically, and we have multiple live demos that you can look at. And also, you can ask questions to members of the DAISY team. So thank you for attending the session. I hope it was useful.